Good morning, my dear kids. In today's class, in the chapter Center of Mass and Conservation of Linear Momentum, we'll discuss some numericals on application of this overall both the ideas, like when to what is the use of the motion of center of mass and the conservation of linear momentum. Means the conservation of linear momentum. As previous classes, we have just discussed about only one some forces are acting. Now, so many forces are there. What are the so many forces like a spring force, the tension, the normal contact, the weight, the friction? When all such forces are acting, how do we can manage that conservation of linear momentum? That will be our primary focus in today's class. That one. So I think I brought many numericals. So please do cooperate. Don't ask me to scroll up, scroll down that one. Just let me share the maximum ideas. This will be very crucial for you because you'll get overall picture like what do you mean by conservation of linear momentum and how to apply it. Okay, let me start the class. Please don't trouble me, sir, wait something. So you have a recording and I'm going to post the PDF. Later on you can manage. Let me start the class. Two blocks are there. So initially this one, so the spring is relaxed. Okay, spring constant is K equal to 2000 Newton per meter. Let's take this one. So what is the thing here, like blocks are given masses, they are given velocities. Initially spring is relaxed, right, it x equals 0, they are kept on smooth surface. It's asking that maximum elongation of the spring. So where is that maximum elongation compression? I think if you go back in the springs, we have just brought this idea, no? When both the ends of the spring have common velocity, then it is right to have maximum elongation. First, what actually happens here? How to decide that uh, maximum elongation? Now look at the momentum, m2u2. m2 is 2 kg, this is 4. So 8 meter per second is the momentum of this block, initial momentum. What about the block m1? 3 into 2, 6 Newton second. This one, 3 into 2, sorry, 3 into
3 to
6,
6,
this will
sir.
be 18. 18. Wait. No. 3 into 3 6 ja 18. So 18 Newton second will be the momentum of this particular block. Then uh, how to decide in what direction they will move? I think both are having initially in what direction the system is having momentum. Initially the system is having momentum towards right. So therefore at maximum elongation both the blocks must have common velocity in the direction of initial momentum. Okay, this is 18. Okay, this is 8. So the initial momentum is in fact towards right only. So first compression or elongation will occur. The momentum of this is more, you can check it. 3 into 6, 18. 2 into 4, 8. So first compression or elongation? First compression will occur. I can't show the complete this one. So let me show only the so here initially this is U1, this is U2. So first now the spring will undergo compression. And this will have some say velocity V21. This will be V11. Okay, this. So and what is the state of spring? Spring will undergo compression. Call Kx1, Kx1. So now finally compression. So maximum compression will occur. At maximum compression both will have common velocity and here show like this Kxm, Kxm. Then after maximum compression again compression will come. I'll do one thing. this as A and B will take it. VA1, VB1. Both will have common velocity. Now VB2, VA1. Now also it will be compression. KX2, KX2. Now next the sequence will be now after this what will happen is natural length it will come. This will be moving with certain velocity. VA3. Spring is relaxed. Maximum compression. This maximum compression, this one. Spring is lax. Now if you go and check it now, VA3 will be greater than VB3. Sorry, VB3 will be greater than VA3. After this, now it will start elongating. So when elongation, so now VB4, VA4. So elongation means how the spring force will act in this direction. KX4, I'll write it. Now what do we get? The next part of the thing is the sequence. What will happen is a student has to understand here. And now maximum elongation will occur. Again at maximum elongation, I'm showing this is the maximum, this is the elongation, this is a compression. Spring is relaxed. So now elongation. So this is the maximum elongation. Again both the ends will move with a common velocity. Now this elongation, the spring will be maximum. I am showing it in this way. Very next moment, the next moment after this, again it will be elongation. Now if you go and check it now, how the spring force is acting in the direction of motion of this block. So definitely velocity of this will become greater than this, or velocity of this will become greater than this. The velocity, you can look at this one. This is the maximum elongation. If you go and check it now, very next moment again immediately it will not come compression. Again it will be elongation only. So at maximum elongation or compression, you see that one. I am more interested in this condition. At maximum elongation or compression, both the ends of the spring must have common velocity. So how to calculate this one? So what is the net force acting on the system along x-axis? Just make observation. Everywhere kx2, kx2, kx4, kx4, kxm, kxm, kx1, kx1. So net force acting on system along x-axis is 0. So therefore momentum is conserved. At maximum elongation or compression, both the ends of the spring must have common velocity. Then only that possible. So here first compression will occur, then elongation will take place. Who will determine that one? Which one is having more momentum? Okay, this one. So here it will be kxm, sorry. No. So at maximum elongation this will be, okay, I'll give one more. Very next moment, sir, can you tell what will happen? VB5, VA5. So again this will be elongation, KX5, KX5. Look at this one. But again, if you go and check it, no, VA5 will be greater than VB5. So this is again an elongation. From maximum compression, suddenly it will not come to maximum elongation. First, what is the sequence? Natural length, compression. Compression elongation will determine if this is having more momentum than this, elongation first will occur. This is having more momentum than this. So what do you expect here? First compression. Compression, maximum compression, then compression, relaxed, elongation, maximum elongation, then elongation. Again after this what you get? Again relaxed. Like that the sequence will take place. Our question is only to get the maximum elongation or maximum compression. So can we take help of conservation of linear momentum? As you see, the net spring force is 0. So applying conservation of linear momentum, initial momentum m1 u1 plus m2 u2 should be equal to, at maximum elongation or compression, both the blocks will have common velocity. Check this one. Both the blocks will have common velocity. Okay, this is the one thing. Next again, how to calculate that xm? Can we apply conservation of mechanical energy? Because what is the spring force? Spring force is the conservative force. So applying conservation of mechanical energy, so we get okay, this is about the maximum elongation. What is xm? Xm I'll call maximum elongation or compression. Okay, do calculation later on. Okay, now what about the velocity of center of mass? Okay, center of mass 3 kg, this is 2 kg. So center of mass will lie near to this. Anything will happen to center of mass. Center of mass will continue to move with a common velocity. Because what is the net force acting on system? Will be 0. So therefore anything will happen to center of mass. Center of mass, initially it was having velocity, it will continue to move with the same common velocity. UC, let me write it. What is that UC? How to calculate? UC equal to m1 u1 plus m2 u2 by m1 plus m2, which is nothing but equal to V, no, common velocity. So at maximum elongation compression, the blocks will be moving with velocity of center of mass. This was the conclusion. At maximum elongation compression, the blocks will be moving with velocity of center of mass. Center of mass will continue to move with common velocity, nothing will happen. Now center of mass, will it undergo displacement? As it is, though net force is 0, but center of mass can undergo displacement. Center of mass is here, now it will come here, now it will come here. So continuously center of mass will undergo displacement. So again, net force 0, delta axiom don't put 0, because initially there is a velocity of center of mass is there. So what is actually happening here? Though net force is 0, net force is 0, delta VCM is 0, but delta axiom non-zero. There is a situation like this because the initial velocity is non-zero, and what is the acceleration of center of mass? 0. All the conditions will come into the picture here. Anybody having doubt, you can clarify. A student has to analyze the diagram, not like just mere I'll write some equation. Sir, why momentum is conserved, net force is 0. Why mechanical energy is conserved? Spring force is a conservative force, and only that force is what doing work. So therefore, we'll go for conservation of mechanical energy. If this surface is rough, then we cannot conserve mechanical energy, because friction will act into picture. Friction does work. Friction is a non-conservative. So we cannot conserve the momentum or these things. Same conditions, little bit different way I brought it. Now look at the initial momentum. Means how to decide that at maximum elongation, compression, in what direction the common velocity will be there. That depends on initial momentum. Look at the initial momentum. M1 U1, how much it is? 3. It is towards left. M2 U2, 12. So net initial momentum towards left or towards right? It is towards right. So therefore, at maximum elongation or compression, how the blocks will be moving? The blocks will have common velocity in the direction of initial momentum. So what is the very important thing? Note, at maximum elongation or compression, the blocks will have common velocity in the direction of initial momentum of system. Now first what actually happens? The blocks here they'll go like this. This I'll call VB. This is a block B and A, no? VB1, VA1. What is the state of spring? Spring will get elongated. Then. And what will be the block 1, block A? It will undergo retardation because of spring force. So it will come to instantaneous rest. There will be spring force will be acting. Spring is elongated. This will have velocity VB2. Is this maximum elongation? No. Very next moment, the spring force, what it will do, will make it to accelerate. Again, we'll get a situation like this. VB3, VA3. The spring force will act in this direction. So what the spring force will do? Spring is elongated now. So now what it does? It will further decrease the velocity of this, will increase this one. So at one instant, both will have. It need not be at initial position, somewhere here we'll put it. Both will have common velocity. So this will be the maximum elongation.
Sir, which means M2 is attracting M1
I'll break your head.
towards
Huh?
it.
Don't say attract. What is the word attract here? Huh?
Means I could not. I mean.
Nothing. Just listen. Huh?
Okay, sir.
Okay, now here the initial momentum, check it. Initial momentum is towards right. So therefore at maximum elongation, both the blocks must have the velocity, common velocity in the direction of initial momentum. Okay, fine. So how to calculate this one? So we're going to apply the net force acting. Very next moment again, what do we get? We get a situation like this. But this is again elongation only. Again, this elongation only. this will be VB4, VA4. VA4 will be greater than VB4. So this is again elongation. So when compression will occur, now this elongation, after this natural end, now compression will begin after this. So how you decide that one? It all depends on initial momentum, that's all. So first you have to analyze the diagram here like this. But altogether, if they ask you just maximum elongation, check it initial momentum. The initial momentum is towards right. So at maximum elongation or compression, the both blocks must have this common velocity in the direction of initial momentum. So initial momentum is what direction? Like this. So therefore at maximum elongation, the velocity of the block should be in the direction of initial momentum. Can we calculate this maximum elongation? Yes, again, net force acting on system 0. So therefore, initial momentum m2 u2 minus m1 u1 should be equal to m1 plus m2v. This is nothing but velocity of center of mass only. Then how to calculate that maximum elongation, kxm, that one. Xm is maximum elongation. Okay, like this, we will find out the maximum elongation. So therefore, suppose now you can ask question, sir, if m1 u1 greater than m2 u2, then at maximum elongation the blocks will have common velocity towards left. That's all I wanted to only discuss this one. Sir, I want maximum compression also. Yes, this is also maximum compression. When will take place? After this elongation, next natural length, compression, then maximum compression. Like that, the sequence will continue. Do calculation later on. Check it, this x2, though it's elongation, this x2 will be less than xm. If you want, you can verify afterwards. So where is maximum elongation possible? Here only. And what is velocity of center of mass? So velocity of center of mass, the center of mass will continue to move. m2 is here. Now also the center of mass. In all the cases, center of mass will continue to move as if nothing is happening. And what is velocity of center of mass? Velocity of center of mass should be equal to v. The same spring constant. Okay, these ideas, where do it will help? It will help us a lot in the, when we go for center of mass, when we go for the collisions, no? So these things are going to help us a lot. Next, I'm bringing some other different system.
So one skill is scroll up, sir.
No, not needed, not needed. Huh? Later on you can. No. 3 identical balls are there. I have a diagram here. Okay, this one. And the A, B, C, identical balls is telling. And the ball B is given velocity V naught. They are lying on a smooth horizontal surface. So what is the other balls? They are at rest. We are projecting. So and these are the strings. They are just out, you can say. So where is the string now? Okay, the string. Now he's asking find the then velocity of A in the direction of velocity of B just before collision. What actually happens here? So after some time, so what do we see? We see a situation there at rest. Let me show sequence of diagram. This you can try all these things at home. These are not something very big. This one. After some time, where do we see this? So initially they are here. After some time, when this is moving here, shall we go for sequence like this? And this will have say velocity VB1. This will have velocity VA1. Sorry, VA. Component of velocities I'm showing it. C, A, this is B. And definitely a tension will be acting, string will be taut, called tension T1. Then finally, what will be the sequence? I think this is not needed. Next sequence, what will happen? At one instant, so what do we see is like a, this will be the ball B. Ball B will have velocity VBY. These will have velocity Bx, By, By, Bx. I'll give the color. It'll be easy to identify. What makes them to move like that? This is very important. Now look at the ball A and C. The tension which is there in the string, so what it does, will end up the diagram like this. Look at the node. The moment I project it, so then they are connected by a string. So what this string will do? So this string, what it does is like it will string will become taut and the tension starts acting. So how do the ANC? ANC will move in a plane. ANC will move in a plane. So they just don't move like this. They'll start moving somewhere here. Then the B, what happened? Has to move along this vertical line. Any reason for that? Because what is the net force on the B at all the time? You look at the component of tension. Because this length is L. Symmetrically it is placed here. In the diagram also given. So therefore net force on the B at any instant of time, if you go and check it, no? Theta, theta. The net force on the B at any instant of time, when you go and check it, it will be along x-axis will be 0. So then what this tension does, it does negative work on the ball B and it does positive work on the ball A and C. So what makes the ball A and C also to acquire horizontal velocity? Component of tension. And the tension will make it to accelerate along y-axis also. So finally, we'll get a situation like this. Now can we say this VBY equal to Vy? Yes, in fact. Just they are about to collide. Okay, this is the condition. So some tension will act here. Let's not bother. What is the net force on the system along y-axis? Now also it will be 0. T1 cos theta, T1 cos theta. So the net force on the system along y-axis 0. So therefore initial momentum equal to final momentum. What is the initial momentum given? All the mass of them be mv naught. What is the final momentum? mvy plus mvy. So what is vy equal to v naught by 3. Okay, this is the initial velocity. Like this we can calculate. So what is this? Is 9 by 3. Just when A and C are about to collide. Now again is asking with what velocity A and C will collide. How to calculate this Vx? We don't know this Vx. Net work done by tension will be 0 here. So therefore I'll go for conservation of mechanical energy. So what is the conservation of mechanical energy? M v naught square by 2 is equal to 3 times of m vy square by 2 plus 2 times of m vx square by 2. Then I know vy, I know v naught. Substituting I'll get vx. Then what is the velocity of A with respect to C along x-axis, or velocity of A with respect to C should be equal to Vax minus Vcx, and Vax equal to Vcx equal to Vx. So it will be Vx minus Vx, 2Vx. So do we know Vx? I'm going to calculate from here. So look at the roll of the string. I think you can just take this any thread, some beads will be there. Mass m and m, no, kinetic energy of this plus this. Okay, y2m, the kinetic energy of this and this. y3m, kinetic energy of all three along y-axis. So all these are some ideas of conservation of linear momentum. Only have to check it net force 0 or non-zero. Net force 0, momentum is not conserved. Net external force is 0, momentum will be conserved. Read the question. Two particles A and B of masses 1 kg and 2 kg are projected in same vertical direction as shown. Find the maximum height attained by the center of mass of the system of particles A and B from the initial position of center of mass of system. Assume that none of these particles collide with the ground in that duration. Okay, it's asking now the motion of center of mass. We have to analyze the motion of center of mass here. So let's take the just have an idea, and initially they are at 90 meters, so this is the ball B, this is the ball A. Okay, this will be on the ground. First understand the situation given, and both are projected with a velocity initial some height is there. We have to discuss the motion of center of mass. Find the maximum height attained by the center of mass. So what method has to be? So just we'll take help of the equations of motion for center of mass. The equations of motion which are there now, that has to be applied for center of mass. So initially where center of mass will be? This will be 1 kg, this is a 2 kg is there. So center of mass has to be near to heavier mass. So therefore the center of mass, I'll locate it somewhere here. It will be near to the heavier mass. So what is that initial height of center of mass we can calculate? So this will be xb. This is xa. So what we can write, maxa is equal to mbxb, and xa plus xb is equal to 90. Solving this, we'll get xa 60 meter, xb 30 meter. This is the location of center of mass. So initially the center of mass is at a height of 60 meter from the ground. What is the initial velocity of center of mass? Everything, let's focus on center of mass only. So first we'll calculate all the innate quantities here. So what is the acceleration of center of mass? ma. What is ma? Ma is 1 into this is minus gj cap. mb is how much? 2. Both will have, this will, what is the acceleration of both? The acceleration of both will be directed vertically down, no? Of course, this acceleration, this is a retardation, but the g for both of them will be acting down. Okay, fine. So this will be 1 plus 2. So how much we are getting? This is the acceleration of center of mass. We'll calculate the initial velocity of center of mass. UC, I'm writing it. So ma ua bar ma 1 into initial velocity 200 j cap plus mb.
Sir, it must be positive now, sir, in the direction of velocity.
Which one?
2 into plus g.
No. Both the accelerations are directed down.
Sir, ball B velocity is directed towards downwards only.
Accelerations, there's a retardation, there's acceleration, but both are directed vertically down.
Yes,
I'm not putting sign for acceleration retardation, I'm putting only sign for the directions.
Okay, sir. Okay, sir.
But
Understood.
according to convention you put.
Not convention, just in what direction they're directed. Acceleration, because acceleration or retardation is the vector, no?
Yes, sir.
So based on that we have to put the direction.
Okay.
Not, see, acceleration, retardation already I indicated in the diagram. So now this retardation what direction? Vertically down. This acceleration what direction? Vertically down. So sign, okay? Now there's the initial velocity of center of mass, will get it. Okay, this will check it, no, this will become 10 j cap, I'll get it. So initially, though you're projecting, the UC will be in this direction. To what height the center of mass will ascend? Previous question, they are on the smooth horizontal surface. I think you have not read question. The blocks are lying on smooth horizontal surface, previous one. So maximum height, the center of mass will ascend is the same thing like how we applied kinematics concept, like find the maximum height ascended by the center of mass. What is the expression for maximum height? H equal to u square by 2g. Here with respect to center of mass, you write it here. So learn, just apply. If you want to describe the motion of center of mass, take help of equations of motion. That's what it's telling. How kinematics you applied for motion of a body, like that you can apply even the kinematics approach for the center of mass motion also. That's what this problem is. I just wanted to conclude that particular point. Sir, if acceleration of center of mass varies with the time, okay, then go for calculus. If acceleration of center of mass is constant, then you use equations of motion. If this AC is variable, then take help of kinematics. there's a golden point. Can you describe the motion of center of mass using kinematics approach? Yes, it is. Calculate the acceleration of center of mass, calculate the velocity of center of mass. Then you can write what is the maximum height ascended. So this will become 10 square 2 into 10. 5 meter is what will get it. 5 meter from where? Initially already it was at 60 meter, no? So maximum height, it will go somewhere. So what is the center of mass? Center of mass will ascend like this and come. Okay, this is the path of center of mass. Already the sign we have put it, no? Why negative sign here? There's only the magnitude you have to substitute, no? H equal to u square by 2g formula. Huh? How do this formula came? By substituting sign only, no? Not thinking, just listening class. Huh? How far I can help you? How you substitute negative sign here? You have to substitute only magnitude, no? After substituting sign only, I got this equation. Okay, this was the maximum height ascended. When center of mass is at maximum height, look at this initial velocity of center of mass. Positive or negative? Positive, no. So initial velocity it will ascend. Karthik, where you are looking, sleeping, look at 10J. 10J is vertically up, no. So it will ascend, then it will descend. Okay, now when center of mass at maximum height, what about these two? Yes, you can calculate here. So what is like a time taken for the center of mass to move from here to here? You calculate that time. At that instant of time, calculate the position where these blocks will be. I think we should not bother now anything about this. Just look at only the equations of motion for this. You may project this also up. When you project this also up. Okay, then change here proportional. Change this one. Then work out. So altogether, see, altogether is asking maximum height ascended. So now from the ground, what will happen? Already it was at 60 meter, now plus 5. So what is H max? 65 meter. So this is the maximum height ascended. From the ground, from the initial position, 5 meter. So this is what? From initial position, I'll pick up here. From the ground, H max dash, I'll write it. Okay, this is what the question that is asked. I'll pick up this one. No, not only like this, the two particles objects can be projected in any way. There's a very generalized one. I'm coming to a very generalized one. So suppose say if I have I will project one particle like this. The other particle I'll project horizontally. Now here also I'm going to ask you maximum velocity of maximum height ascended by the center of mass. So let this be theta. So m1 2 kg, m2 3 kg, u1 10 meter per second, u2 2 meter per second. Theta, let it be 40, 30 degrees. Then what is the motion? The path of this will be like this. That's all. No, it is going to move horizontally. What about this one, which will have more horizontal velocity? U1 cos theta, 10 5 root 3. So definitely what happened? So this particular thing is going to go and strike the ground somewhere here. I'll ask you now, what is the maximum horizontal displacement of center of mass, maximum height of the center of mass? So in this case, again, what is the method like? What is the maximum range of center of mass? Then what is the maximum height ascended by center of mass? So here again, initial velocity of center of mass you are going to calculate. So how much it is? 2 into u1 sine theta plus 2 into, this will be 0, sorry, 3 into 0 by 2 plus 3. So this will be 2, u1 is how much? 10 sine 31 by 2 by 5. 2 meter per second. How it will be directed? Vertically up. From here it's going to ascend. Okay, what about the acceleration of center of mass? I think that we can proceed in the similar way. m1 into, the weight of them both will act down, no? G plus 3g by 5, and how it will be down. So what actually happens here? Maximum height ascended by the center of mass should be equal to uc square by 2ac, 2 square by 2 into g, 2 by 10, 1 by 5 meter. Somewhere here, so 1 by 5. Calculate this maximum height ascended by h1. What is h1? h1 should be equal to u1 square sine square theta by 2g. u1 is how much? 10 square, 1 by 2 whole square, 2 into 10. 150, 2.5 meter.
1.25.
The maximum height, this is what? 1.25. What about the center of mass? Center of mass will be less than 1 by 5, 0.2 meter only. So somewhere here, how the motion of center of mass will just ascend? No, it is going to describe a path like this here. Able to make it out? So what is the green color one? I'll show the path of center of mass. So how the center of mass is going to go? This is the path of center of mass. This is what the maximum height ascended by the center of mass. From the initial position, from the ground, 500 plus hc. So not only just vertical, two objects project in any direction. So you can bring the even projectile motion for center of mass also. Are you able to understand? At what distance the center of mass will finally strike? If you can calculate that also. This is a very generalized discussion. I just wanted students to have general idea. If I solve one question, you just remember what all we discussed, projectile motion, can we apply for center of mass as the range, time of flight, height, all the kinematics you can apply for even center of mass also. This is a core central idea of the discussion. Agreed? You have to analyze whatever question they'll ask you, you have to check and we have to work out. Means like, sir, after some time when it is here, where the center of mass is, then calculate that time and apply the equations of motion for motion of center of mass, then you can calculate the position of center of mass also. Generalization is very, very important. Students, analysis is very important here. I read the question. Suppose a cannon of mass m fires a shell of mass m with initial velocity u related to cannon at an angle theta to the ground. In the process, cannon recoils freely. Then, range of projectile is asking. Carefully read the cannon. It is made to recoil. What do you mean by cannon? I think one which will fire projectiles. So usually I think you might have seen, no, whenever you fire it, what it will recoil back. If you don't allow recoil, okay, fine, what we discussed, but basically it will undergo the recoil. So when it undergoes recoil, what conditions are there? That is what we are studying here now. Start working. So now you know many ideas, no? It's not that something this is new. Yesterday we have discussed some conservation of linear momentum, so those things is what one has to take help of here. Okay, first we'll begin like this. So this is the this is a cannon. I'm showing it. So this is M. If this is a fixed here, and it will fire a bullet, small m. So what will happen in that case? It is going to, I think we'll make it here. It is going to describe. So this particular thing is going to cover a range, how much? Say like a R. Or say R naught. Okay, this is the angle theta. You're not permitting it. That is going to describe the range R naught. So it will with what speed you fire, with a velocity u related to cannon. Okay, this will become absolute velocity. I'll call UR, U as UR. What is the expression for this range? R not equal to 2UR, or select UR square sine 2 theta by j. So from where this projectile motion, what is the cannon? Cannon, we are not permitting it to recoil. Now let the
Sir,
cannon.
we are doing here. It is recoiling freely, sir. This design.
I'm not getting.
The cannon recoils freely, sir. Here.
I'm comparing. No, please allow your teacher to discuss first. In the end, you can clarify. Huh? Now the cannon is fixed. Okay, this was the range that will happen. Now the cannon will recoil. The cannon will recoil. Now we will bring the situation of cannon recoil. If the cannon recoils, what will happen to range? Range of the projectile. So cannon recoils means, so when you project it, so cannon will recoil back. Okay, let the velocity of the recoil, velocity of the cannon, let it be v2. Here the cannon, the shell will have velocity ur, and it's going to describe a trajectory. We don't know it will be less or more. That is what we have to check it. At an angle theta with respect to. Now what is the cannon? Cannon is going to recoil. Cannon moves back, or just say cannon recoils. This was the learning. First you have to learn it. If you fix the cannon, okay, fine. If the cannon recoils, then what will happen to range? Because usually basically the cannons will be, though it is made heavier, still because of the momentum given to the shell, no, it will recoil back here. Can we apply conservation of linear momentum? Yes. So what is that? All the firing of that one, the internal forces will act. It's still, we can bring the net force acting on system along x-axis to be 0. We can work out the problem here. So what is the velocity of the shell is needed? The shell will have horizontal velocity vx, v1x and v1y. So how to write that equations here now? Applying conservation of linear momentum. Net force on the system along x-axis 0. So initial momentum equal to final momentum. Initial momentum, it was a test when we were firing the shell. Final momentum, m v1x minus m v2. What is v2? v2 is the recoil speed of the cannon. Now, okay, what is the thing now? So ur we have plus ur equal to v1x minus of minus v2. Okay, we'll get the v1x now. So I'll substitute 0 is equal to this v2 is what I should replace. Let me go for replacement of v2. v2 will be ur minus v1x. First we'll do one thing, we'll calculate. I think straight away you could have written this is the recoil speed of the cannon. Now shall we calculate the v1x, because that is what going to help us. What is v1x is equal to, I'll substitute in that formula, ur this is the horizontal component of velocity of the shell. So what is v1x I should call? Horizontal component of shell with respect to ground. What about vertical component? Vertical component is just ur sin theta. And we'll determine time of flight 2v1y by g. So 2ur sin theta by g. That ur is nothing but u, already I indicated. So shall we calculate the new range? The new range will be v1x into t. What is v1x? mur by small m plus capital M. Okay, look at now m small m capital M 2ur square sin theta by g. ur cos theta. Okay, so some error here. Horizontal component, no, ur cos theta. I have to change everything. Velocity of the shell along x-axis, not ur cos theta. Here we are going wrong. This also will change.
Sir, MUR cos theta you can make.
Yeah, mur cos theta will come. Let me only, I think this part I'll change it. v1x minus v2. Okay, there's a thing. So we are everywhere I should do replacement. Okay, v2. Okay, there's a v1x, we got it. So 0 equal to m. Yeah, small change. So v2 equal to mur cos theta by small m plus capital M. So v1x I am going to substitute here. So this will become ur cos theta. v1x will be, after substituting here I'll do one thing. Solving will get it. v1x. So here ur cos theta will come. The two diagrams are very important. Okay, this will become cos theta. So this will become capital M, small m, into, this will be, shall we write it as R naught or UR square range, will it be less than R naught or greater than R naught? That's the only thing which I'm asking here. Definitely R will be less than R naught. So if the cannon recoils more, what is the problem? The range will decrease. So therefore making cannon heavier is very important. If you make cannon heavier, transportation is a big problem. I think that's what, if you just go back some 100 years back, the cannons used to win the battle. Okay, now we have aeroplanes, everything, tankers, no? Just 19th century, prior to 19th century, the cannons only used to win the battle. So to have the more range, so what is the problem is like, there's the thing, if the to increase the range, the mass of the cannon should increase. If the cannon's mass increases, then what is the problem? Transportation was the problem. So there used to be like the one who are having good cannons, they used to win the war. War is all about the weapons, no? Now also in India, we have so many enemies there. So, if you want to win the war, what happens? We need good weapons. How good weapons will come? Students should think, analyze, then only the nation will become powerful, no? Just mere looking, listening, not possible. We should protect ourselves, no? Who knows that tomorrow some 2, 3, 4, 5 countries, they come together, they may capture different countries, exploitation, anything happens. So we should protect ourselves. So to protect ourselves, what happens? Just emotions not needed. I think there's a message. Shesha movie, I think most of you might have seen.
Yes, sir.
Yes.
Shesha movie, most of you might have seen. So what is the problem? There is like 543 soldiers Indian died. If you had a good weapons, most of you are very emotional. Just imagine during that movie, I felt like if we had a weapons, no need to any person die, no. See, soldiers are courageous, they came forward. The lack of good weapons, what happened there? 540 soldiers died here. If good weapons were there, India easily what happened could have managed, no. So these are the problems what we are having. We are more emotional. But see, wars are won by weapons here. See, brave soldiers will be there. For brave soldiers, if you good weapons, what will happen? Still more very easy, no? So we didn't have good weapons. You can see that in that movie, no? We didn't have good communications. We didn't have good weapons. Nothing. Just only the courage and the brave of that what happened made we are able to win the battle. How many sacrifices we have to do like this? Lack of technology. Then what is the problem? Okay, we are more bothered about cricket. We are more bothered about movies, festivals, this enjoyment, happily sitting. Teachers should discuss more numericals. We will just only listen. This is what happens. Like this, millions of soldiers have to sacrifice their life. You should take textbooks, start reading, analyzing, think, get that scientific technology. Then only something will happen in the nation. Otherwise, like this will continue. This scenario will continue. We have countries which are more advanced than us weapons. If they attack us, what will happen? How many people we have to sacrifice? Just think on it. You have got some responsibility, no? Are you just a student? No. You are something you are supposed to contribute the technology, no, to the nation. How it will come? Until you don't work out, draw the diagram, think, analyze. So these are the major problem what we are facing. It's a very sad to say that none of you are interested to learn science here. I don't know what is your goal, everything that one. You have supposed to analyze, think, fight. So look at your teacher, how he is drawing everything, thinking, analyzing. No? The scientific analysis is missing. We are all about some sort of like somehow preparing for exam and going out. So you'll get a rank, certificate, finish out. Who will solve the nation's problem? Who will provide weapons? Who will solve our roads? Who will improve roads? Who will improve buildings? We need lot of technology for such a big nation. I'm telling the lot. 1/4 of population resides in India. So we have so many problems. We don't have thinkers here. That's a major problem. We are totally dependent on the other countries for the technology. So unless students doesn't change. So what you do with the government? So government is not permitting you to think. Who is stopping you from analyzing all this? So we'll blame research institutions, we'll blame that one, this one, nothing. See, science doesn't need anything, just need good thinking brain. Finish over. You need not to blame anybody else. So we just blame so many other XYZ reason. Nothing is there. Just take books, start reading, analyzing, analyze scientifically, finish over. Such thing is what we are lagging. That's why we are more dependent on other countries for the technology in all the fields. As long as this happens, no, the sacrifices will be there like that. So these are the major problems we are having. Not thinking. That's all over. This thinking is not there now. Even when you get into ITs also you are not thinking. The process will continue. Okay, next we'll take the next one. Square plank. Okay, usually we discuss the recoil of a plank, no? But here what will happen? We have a square plank. One person will walk like this, other person will walk here. Then we are supposed to calculate the displacement of the plank. The plank I'm showing by yellow color. So usually the trolley we did know, the plank something trolley here. So let be two-dimensional things what we can study here now. Now individually you can assess the motion like a superposition principle. You can have it. One. Okay, let this person. This the M1 is the mass of the plank. This is the M2. This is M3. First M2 will walk. It will have displacement plank like this. Then M3 will walk. Then you'll have displacement. When both walk simultaneously, what to do? Take the superposition principle. So the plane diagram I'll show it. I can't show the 3D diagram. Initially, let's say this origin. Read the very fast. You have to read the question. Here is what the plank is there. I'm telling once again, we need weapons. We need technology very badly. In all the fields, we are lagging. We need technology to solve our society's problem. Our soldiers need good weapons. That one everywhere. That one. Our civilian people need good technology to improve their lives. So many things are there. Just what happened? We are copycatting things, and how we are applying, we don't know that one. So this has to end up. We should have our own. We have our own requirement. The technology for our own requirement should come, not for somebody's requirement. Importing technology is not good. Such a big nation, 140 crore people, we are importing, we are requesting everything outside. 140 crore, such a big population. Okay, this is M1. So as they start walking, here I'll just show only dot like this. It'll be easy for us. So as he starts walking, so suppose only M2 will walk like this, so it will recoil like this. If only M3 will walk, it will recoil. So definitely when both they walk, yes, the plank will recoil. The plank, let's assume somewhere it will come here. There's a rough diagram to make you understand. I'm just making a guess. Maybe it is somewhere here. Okay, this is now M2, this is M3. So when this has reached here, further move it. After calculations, exact diagram we can go for it. So time being is what we are putting here now. How to get that x displacement? So it is having, you can see x displacement, y displacement. So this will be the x displacement. This will be the y displacement. That has to be calculated. So here M2, this M3. Now, directly how to calculate xc. I don't know to write equation. Already you have enough of the four problems we have discussed here. We have discussed some very good number of numericals on this. How to calculate the displacement of Any formula xem mass of the system. Actually, what's happened? M3 will move only along x-axis here. M2 will move along y-axis. Who will determine the displacement of Planck along y-axis? The M2. Who will determine the displacement of Planck along x-axis? The M3 and this one. So xc should be equal to M3 into L. So let the side length is L I given by total mass of system. What about yc? M2L by M1 plus M2 plus M3. Sir, why you are bringing? Okay, fine, sir. M1 and M2. Why you are bringing M3? Total mass of system. You should not skip here M2. You should not skip here M3. And what is the direction? It should be towards left. Put negative sign. Substitute the values, you'll get the answer. So even we can have this particular motion in 2 dimensions also. Okay, now we'll take the next one. This will be really, the wedge will also move. Is asking the displacement of wedge. And what is this? This surfaces are rough. This surface is rough, I'm calling it. Find the displacement of the wedge. Okay, one block, person walking on a plank, okay, no. Person walking on a plank, something, okay. But something like this here, how do we can calculate the displacement of wedge? The best formula is like M1 delta x1 plus M2 delta x2 plus M3 delta x3. So what is the question that is asked? Like 2 blocks M1 and M2 are connected by massless inner core, that is powered or light pulley. Wedge of mass M3 which rests on smooth horizontal plane. The horizontal displacement of the wedge would be when M1 slides down by L along the wedge. So when it moves a distance L. So what is this L? This L is the displacement of the block or the distance moved by the block with respect to wedge here. So that understanding of L is very important. Displacement of block M1 with respect to wedge. Then how much M2 will move? It will be downward, no? It will be directed downward. How much of distance then M2 will move? How much this has moved, that much it will move with respect to wedge. That's all, no? I think we have laws of motion. They're connected by common string. If this moves by 1 meter with respect to wedge, this will also will move 1 meter up. So what we have now, the motion of the block with respect to wedge, we know it. So then he's asking how much of horizontal displacement of the wedge. So I think the best thing is like we have to go for the displacement of 1 with respect to 3. It should be equal to x1 minus x3. How much it is along x-axis. The block M1 will move a distance L with respect to wedge along x-axis. If this is a distance L, this is alpha. Along x direction, how much it should be? L cos alpha. So what is the direction? Towards left. Okay, this will do one thing. Towards left, you can take positive, or we'll keep it here, convention. So minus L cos theta. Don't draw diagram. It's not advisable. You should take help of formula. This is delta x1, which we don't know, and this is unknown thing. Keep it here. Now, what direction the wedge is moving, in fact? Wedge, what direction it will move? Let's assume that it will move towards left. Towards left means put minus x3. Or take help of the sign. These are unknown things, I don't know. So therefore this will become x3 minus L cos theta equal to delta x1. You have to recollect previous problems we have discussed, some questions related to this. Can you remember? So that M1 delta x1 plus M2 delta x2, the same conventions a student has to apply here. Now, sir, why you are not putting any sign for delta x3? The displacement of wedge, let it be delta x3 will write it. And this is what needed. Now similarly, I'll go for x23. x2 minus x3. So what is the displacement of the block 2 with respect to wedge? L cos theta. This is also towards left. Then this we don't know. This also we don't know. So therefore delta x3 just mere formula. Okay, delta x3 plus L cos theta. L cos alpha, no? Some symbols. Okay, we go this one. So I'll directly jump into the formula. M1 delta x1, M2 delta x2 plus M3 delta x3 equal to 0. M1 delta x1 okay, delta will be, so this will become M1 L cos alpha, M2 L cos beta by, I got positive sign. What does it mean? It will move towards right, displacement. Towards right here. So like we are not understanding anything. That's what I'm telling you this one. The formula is what made everything. But what actually goes on? What are the various forces that are acting? Okay, now even, so like actually you are not shown any free body diagram also. Straight away you went for writing this equation. Assuming that we know all these things. Okay, somebody has asked us, sir, how you're writing, why you are writing the equation. Why you are writing this means already we had the discussion of laws of motion chapter. Since you know, assuming that I went forward. Okay, now I'll show all the forces acting here now. What are the various forces acting? M1g sine theta. The friction on the wedge, tension, normal contact, mg cos theta, tension, here tension, m2g sine theta, friction F2, then on the wedge, this F1. There's a normal contact N2, m2g cos theta, the weight of the wedge, and the normal contact from the ground. You look at the net force acting on the system. Net force acting on the system is 0. So how do you can see? You look at this, plus F1 cos alpha minus F1 cos alpha. F2 cos beta minus F2 cos beta. N2 sin beta, N2 sin beta. Here N2 I am not unable to. N2 sin beta, N1 sin beta, N1 sin beta. T cos alpha, this one. So here T cos alpha, T cos alpha, T cos beta, T cos beta. Net force on system along x-axis 0. Therefore, delta xcm is 0. That's why I am writing this one. So whether this surface is rough or smooth doesn't matter. So you get the same answer. That shifting one, I think just formula based, you can do by diagram, it will be very difficult. You should take help of formula. Even the blocks are moving in a plane, still for x displacement you can take help of this one. Sir, what about y-axis? Y-axis, will it undergo any displacement? Yes, net force on system along y-axis non-zero. This is what happens. The use of formula, student must know how to use that formula. Very, very, very important. Take the next one. A train of mass m moving on a circular track of radius r with a constant speed v. The length of the train is half the perimeter of the track. Okay, there's a track I'll bring. The linear momentum, it is moving with a constant speed. Okay, we have like this. So where is the train? So the train, you can assume it to be like this here. This green color is what? The length of the train is equal to half of the perimeter. And mass of the train is m. So what is the speed of each and every bogie? Will be same, but the velocity will be different. The radius of the track is giving it is equal to r. What is this momentum is asking? So momentum is a vector quantity. So what we should do here now? How to calculate the linear momentum of the train? Perimeter, half of the perimeter. Half of the perimeter means what is the length of the train? Length of the train should be equal to pi r. Every point will have the velocity v. Every point will have the velocity v. Okay, I'll do one thing. I'll give one more diagram. There's a rough diagram what actually is going on. So every point here, this point will have speed v. How the speeds are directed? Okay, these are the speeds of the train directed, no? So different points will have different velocity here. It's asking momentum, and momentum is a vector quantity. Shall we add up just like a speed into the mass? Mass of the train is how much m? Speed is mv is our momentum. No, not like that. Momentum is a vector quantity. So therefore what shall we do is, first we'll assume a small element here. Symmetric elements, let me pick up. This also r. So what is the momentum of this? Will be v. This is v. So mass of this is dm, this is dm. Okay, this is theta, this is theta. So let this be d theta. Momentum is a vector quantity, so first we'll calculate the momentum. I think the xy component will get cancelled out. You see this one? So if this is theta, this angle should be theta. If this is theta, 90 minus theta, this will be theta. So we'll go for this is theta. Similarly, you resolve this. So this will be theta. So which components will get subtracted? The y components will get subtracted. So dmv sin theta will be vertically down. dmv sin theta vertically up. Horizontal components will get added up here. So here we'll go for dpy. Dpy of the system will be dmv sine theta. So this will be 0. What is the net momentum along x-axis? Along x-axis will be dmv cos theta. Both will get added up. Now what is dm? Lambda will define should be equal to mass by perimeter. So dm should be equal to lambda into ds. So what is the ds? ds will be arc length. Then what is the mass of that? Lambda into ds. Can you remember? We have done so many problems till now. So now keep as it is, lambda into ds. This is v, this is cos theta. ds is further what you can write? r d theta. What should be the limit? This is theta equal to 0 degree line. So 2 lambda Vr cos theta d theta. I want limits from the student. I'll add up momentum of this. I want the limits from the student. I assume two elements. So if I rotate this d theta from 0 to 90, I'll get momentum due to this. Since I assume two elements, 0 to pi by 2.
0 to
Integral of cos theta this will become 2 lambda Vr sine pi by 2 sine 0. So the momentum is equal to 2 lambda Vr. What is the lambda we assume? M by pi r. And how it will be directed? The net momentum of the train will be directed like this. Okay, this one, so I think at curved points is very important in designing of the tracks. Opposite to the momentum, there will be force acting by the track on the train. By the train on the track will be in opposite. So there, the designing of tracks, all this matter. That's the main purpose of discussion of this problem. Usually we discuss momentum of a particle. A block is moving. Okay, fine. Something, some object, some rod or some sort of like here, this one, and a body. If it is moving, if the different parts of a body is having velocity in different direction, how to calculate momentum? One example I am giving it. What we defined is momentum for a particle, mv. Okay, very good. But this is not a particle, it's a body, no? And the different points are having momentum in different direction. In that case, what is the method? Assume small element. First define the momentum of small element, then go for integration and look for any symmetries there. Because of symmetry, what happened? We are able to minimize the mathematics here. This is a method. So momentum of a particle, momentum of a body. If the whole, suppose that this train is there, train of length L, mass M, moving with a velocity, there's no problem. mv will write it. If it moves along a straight line. If it different parts of a body, if it is having velocity in different direction, no, then what we should do? Assume small element, define the momentum of small element, then go for integration. There's some background of regarding the momentum of a bodies also. So many objects are there in your room. Take blanket, different parts of the blanket remove in different direction. Can I find out the momentum? Yes. Analyze it. What is there in that one? Sky is a limiter here in the science and technology. If you are genuinely interested, no, I think even this problem solving itself, what will become a sleep, will become a food. You don't get tired also, because change of work will become rest when you enjoy science. Okay, reading physics. little bit you feel like, okay, some fatigue, then read chemistry. This is what happens when you enjoy subject. When you don't enjoy subject, then every problem you need rest after every problem. Okay, this one, this is some, we'll go back to some application of conservation of linear momentum problems. Here, there's a block, there's initially the wedge is at rest. What actually happens to the motion of the particle and the wedge? I'll help you with through diagrams. Okay, there's a particle, or there's a block, okay, like this with a wedge. I have to carefully analyze the system. So the block will climb up. So initially, what is the state of this? This is at rest. All the surfaces are smooth, it's telling. Now, what are the sequences that will take place? So the block starts climbing on the wedge. At the moment the block starts climbing on the wedge, what conditions will come? Normal contact. All these are really diagram based questions, so student has to fight with a diagram. Let me bring all the sequence of diagrams. This what finally, I'll show a complete description. This will be very fundamental and very important for students to analyze this one. Conservation of linear momentum, the velocity of center of mass, all those ideas. What actually happens here? So the block initially, a very good problem of conservation of linear momentum and center of mass. I think, okay, all the sequences are there in front of us. No. Let's begin that one. So this was having initial velocity u. This wedge was at rest. Now it starts climbing. The moment it starts climbing, what are the forces? Everyone please put effort, try to understand things. Here normal contact, you start with this one, n1. m1g cos theta, m1g sin theta, and it will have some velocity, say, with respect to, let it be wedge only. So with respect to ground, it will have some velocity, UR, I'll write it, with respect to wedge. Then n1 will also act on the wedge. And because of n1 sin theta, what do we expect the wedge? Wedge will start moving. Means the moment the block starts climbing onto the wedge, n1 sin theta will act on the wedge. And because of that n1 sin theta, the wedge will start moving towards right. So this will acquire velocity, say v2. Okay, fine. Okay, now how long this will occur? Now the weight m1g sin theta, what it does? It will make the this velocity of the block with respect to wedge will start decreasing. At one instant, both will have common velocity and will be moving towards right. Still continue same thing. N1, this N2. The weights are acting. Then it will come to rest with respect to wedge. Then on the from ground frame, when you see what will happen, both are moving with a common velocity. You are going to see that. And then, so because of component of weight, now the block weapon will start moving with respect to wedge. Now, if you stand on the wedge, the person on the wedge, what he says, block is at rest at this moment. Person on the ground, what will be comment? Both block and wedge are moving. At this moment, only at this moment, at that instant, for a fraction of time, this will happen. Person on the wedge says, yes, the block is at rest. Agreed. Now again, what will happen? M1, this person, what he says, M1G sin theta will start acting. So now, what is the motion of the block? The block and the wedge will continue to move towards right. Okay, V2 dash, you write it, or V3 sum. Then finally, this is what happens. Okay, I think. Finally, what happens? The wedge will be moving towards right, and the block will be moving towards left. In all the cases, anything will happen to velocity of center of mass. The center of mass in what action? Because what is the net force on system along x-axis? N1 sin theta. Here also you write N1 sin theta. Students, they don't want to draw diagram, directly they want answer. That's why I have to show all these things. Otherwise, we have done so many problems in laws of motion. You are supposed to think. Only teacher should say that net force on system along x-axis 0. How it is 0? By the time students should have all this background. See, where you are going wrong. I am scolding very bluntly so that you should get hurt and you should realize something. There is a big problem is there. Actually, how I should solve the problem? Teacher just should say that the net force on the system along x-axis is 0. So therefore, you can apply conservation of linear momentum. This idea, this is enough. As a teacher, I should teach only physics teacher. I should teach only this much here. But there's a problem. Sir, are you want to get rid of your job? No, my job is not to dump numericals. I should make you to think, no, but that thinking from your side should come, not from teacher's side. Look at here at all the sequences, N1 sin theta, N1 sin theta, N1 sin theta, N1 sin theta. Everywhere, the net force on system along x-axis is 0. Can we apply conservation of momentum? S. M1 U should be equal to minus M1 VA plus M2 VB. Can we calculate? Yes. We have all the information. So, but sir, both are unknown. What to do? Can we apply conservation of mechanical energy? Net work done by normal contact on the system will be 0. So, who is the only? Then the weight also. Weight is the conservative force. So, net work done by gravity also 0. So, therefore, the kinetic energy of system will be conserved. So, M1 U square should be equal to M1 VA square M2 VB square. Like this, I think solving equation 192. Solving equation 192, we will get this final velocity. What about the center of mass? Center of mass will continue to move in the same direction. Nothing will happen to it. Center of mass of system somewhere here For your understanding, I'm putting here. In all the diagrams, you just show it, center of mass will continue to move its same velocity, as if nothing is happening. Center of mass doesn't bother, like it will just the block has ascended, descended, it will try to continue to move, but it will not be here. So look at here, center of mass, where the center of mass of system has to be here. No, it has climbed up, it is somewhere here. No, but it will continue to move. With what velocity? With a common velocity. How to calculate that common velocity? How to calculate this velocity? Because it will rise to certain height. You look at the block has rise to certain height. Let me show by its other color. Then applying again, m1u equal to m1v plus m2, and this v equal to m1u plus m1 m2. This is nothing but velocity of center of mass, no? Any reason for that? Net force on system along x axis 0. Then how to calculate the height to which it will reach? Do we have a formula? Yes, we know v from here. So the initial data is given. So to what height it will rise, that also we can calculate it. What is the question? Find maximum height ascended by block A on wedge. That is what that h. So what is h we should call? Maximum height so again the block will not be there only because of m1g sin theta, it will start sliding down. So in all the sequence here, center of mass will continue to move with a common velocity, will continue its velocity, uniform velocity motion, as if nothing has happened, as if the block has not climbed anything. So I am writing UC now VC. Okay, we'll do one thing. Same symbol will continue. Make observation. Any doubt you can clarify. Any doubt if you have, you can clarify. The complete problem description is available. Next question. Sir, if the surface between the block A and the wedge, if the inclined plane is rough, still can we apply conservation of linear momentum? I want answer from students. If the
Yes, sir.
inclined plane,
Yes.
yeah, we can apply it. But can you apply conservation of mechanical energy?
No, sir.
No,
No, sir.
because
Non-conservative.
non-conservative force does work. These are some observations one has to make here. Whether inclined plane is rough or smooth, momentum is conserved. Mechanical energy is conserved only when all the surfaces are smooth. Inclined plane smooth, momentum, mechanical energy is conserved. Inclined plane is rough, momentum is conserved, mechanical energy not conserved. Inclined plane is smooth. Both momentum and mechanical energy is conserved. Momentum is conserved and mechanical. Way to write this. Is not conserved. This I'm telling this one. This chapter is especially this conservation of linear momentum. No, you have to pick up some best numericals which are diagram based, not like some particle, some equations. Okay, fine. It's a mere mathematics here. You have to pick up numericals where some wedge block, springs are there, strings are there, some various different forces are acting, how momentum is conserved. Finally, that is what matters a lot. Not just mere some equations, okay, some integration, differentiation. They're all math based. Will not help you much. Let's take the a stationary body. Okay, we are discussing some idea of center of mass here. Okay, now clearly you can see the diagram. Question, I think it's visible. Okay, let's go for this one. All of you, first read it. Let me bring that x, y, z axis. So we have an object. Okay, this is our object. A body of mass m explodes into 4 identical fragments. This is initially. So this is the x-axis, y-axis, z-axis. Then it explodes here. So explosion. So what is explosion? Explosion is an internal phenomenon because what are the forces acting? The forces will be an internal forces because all their chemical reaction, no? It's an internal forces. So because of that, so we'll get a fragments. One fragment will move like this. One fragment will move like this. It will explode equally into equal fragments, himself is telling. What about the third fragment? How do you tell me? So equal kinetic energy. So they are having same kinetic energy. So let's put K. Because of kinetic energy, they will have momentum. How kinetic energy and momentum are related? So they will have the velocity C, B, B, B. Kinetic energy, I should not show direction. Let's go for it. So then, what is the kinetic energy equal to? M by 4 by 2 P square. This was the basic idea. This one. So this will become mv square by 8. Then I wanted, so there's the individual, what is the momentum of individual particle? We'll check it. Like an expression for V. V is what? 8k by m. So what is the momentum of individual particle? Px should be equal to m by 4 into V. This should also be equal to, I have space here, Px equal to Py equal to P, only magnitudes. That should be equal to, mass of each fragment is m by 4 and the speed is V. We have just now calculated. So this will become 8 mk by 16. Mk by 2. If you're finding difficult, no, you can apply this method. So this is the initial momentum of individual fragment here. Now it's asking center of mass of system after collision will be. Okay, let's go for it. Now the explosion has taken place. What is the basic explosion? So what forces are responsible for explosion? The chemical forces. The chemical forces and what all the chemical forces that are acting, the molecular forces, they'll become internal to the system. So therefore, during explosion, what all the like a molecular forces that are acting, they'll treat it as an internal force. And due to internal force, center of mass will not accelerate. So what do you expect? The center of mass after the explosion. Initially it was a test, now also it's going to be a test. Center of mass will not move. So center of mass where it is going to be there only. The reason for that, what is the reason we should give? During explosion, internal forces will act. During explosion, internal molecular forces, let me write it, molecular forces act here. And we know due to internal force, center of mass will not accelerate. So what was initially system was a test. So finally after explosion also, center of mass will be there only. Can we apply conservation of linear momentum? Yes, the net force on the system is 0. So what direction you will apply conservation of momentum? In a space. So initial momentum equal to final momentum. So what is the initial momentum? 0. Final momentum, we have that one, px I cap, py j cap, pz k cap, plus the momentum of the fourth fragment we don't know, p4 bar. So how it should move? That's what we are making a guess here. Now do we know this, all this value? Do we know the momentum? Yes, it will be how much it is, root m by k, this I cap, so somewhere in a space the fourth fragment will move. Speed of fourth fragment is asking. There is a momentum what we have. I want speed, so what shall I do? I think what is the momentum? How you define momentum? Momentum should be equal to the fourth fragment will have mass m by 4 into v4, no? So what is the magnitude of this? Will be root 3. Okay, now substitute this. So now due to explosion, the center of mass will not shift. That's the basic idea what we have brought it here. Okay, now V4 is needed. So this is equal to 4 into PV4 by M. Vp, this is equal to M or 3 mk by 2. K by m. What is V4? Speed of fourth fragment. Total energy released. What do you mean by total energy released? So what was the state of center of mass? Center of mass was at rest. Now due to explosion, center of mass will not shift. The fragments start moving. So the kinetic energy of fragments is nothing but the total energy released here. So what is the next part of the thing? Energy.
Speed of fourth fragment is
Energy. Energy release should be equal to kinetic energy of fragments.
Sir, 2 under root 6 cubic.
speed should.
2 will be there, huh?
Yeah, 1
Yes,
extra 2 should be.
Yes, sir. 2 into under root 6 cubic. Yes, sir.
2 into here 1 2 is missing, no? Yeah, fine. Or we can send total, no? Okay, let's write based on this option. Okay, now kinetic energy of fragments. What is the kinetic energy of fragments? The 3 fragments Three of them fly with perpendicular to each other with same kinetic energy. Okay, K plus K plus K. The fourth one is what? K4. How to calculate the kinetic energy of the fourth fragment?
Velocity we have.
mv4 square. So mass of the particle is m by 4. Okay, then we know the speed v4. So this should be equal to 3k plus, this will be m by 4. V4 just now we have brought it, 2, 6 square, no? So this will be 4.
Yes.
6k only will come.
Yes, sir.
There's a total energy released here. So now center of mass, what happens? Though the fragments will be moving, center of mass will be there only. So center of mass, where it is there, so initial portion where you kept that particular explosive will be there. I think during Deepavali festival it will happen. Now that particular flower pot, no, or so some other things are there where it will get burst. So usually it will be at rest, no. So you explode it. Where the center of mass of system will be, where initially that particular explosive there will be there only. The fragments will be moving with the different velocities in different direction. Any doubt if you have, you can clarify here. So that calculation of center of mass, no, it is a just mere mathematical one. I think, are you getting now that the real concepts are here now? But I don't know the books material, they have dumped more on finding center of mass, finding the center of mass. But final exam advance, none of the questions came on finding the center of mass. You should know the center of mass of various objects, that's all. The motion of center of mass, conservation of momentum, these are the things which are going to help us a lot for the coming chapters. Not like, see, center of mass of what, like solid cone, hollow cone, some well-defined geometrical shapes, if you know it, is more than enough. But it got deviated because they are like a more mass based, so they are dumped questions like anything. Today I suggest to everyone, don't take any numericals on finding center of mass of an object, because it is of no use. Already you know for a triangular plate where it is there, square plate you know, semicircular plate, just if you know it is enough. Beyond that, not needed for us.
Sir, for paraboloid and all those shapes not required, sir?
It's there, okay, workout. But
Okay, sir.
now today you have to focus on the conservation of linear momentum numericals only. Plenty of examples are there.
Okay, sir.
Today and tomorrow, just work out more on the conservation of linear momentum. We'll have class, some half-an-hour class after break. Huh?
Okay, sir.
Okay, kids, like we had the discussion on the different types of numericals based on the conservation of linear momentum. Means like, what is the main theme of such thing is like, under action of various forces, under action of like a spring, the tension, friction, weight, the normal contact, when all such forces are acting, how do you conserve the momentum? I think this matters a lot. That's what finally our purpose is, to work out under action of all forces, can we conserve momentum in various types of systems? These are the discussion which you have to focus here. So try to pick up numericals related of these kind only. Okay, thank you all of you.